So good morning, thanks Eileen, and thanks Sofia for the wonderful speech and magnificent talk before mine, as I would say. So and you can skip a couple of maybe a couple of slides. So I really would like to thank you, the organizer of this conference. I mean, it's amazing networking, and really a great opportunity to bring all together, speaking about childhood and the mother-infant nexus. That is my interest. It's come also from my ERC starting grant project that is called MOTHERS. Is the acronym for Modeling the Evolution of the Mother-Infant Nexus. Okay, so the Nexus, I mean, also we had in the first day, many of you that spoke about this, the importance of the Nexus, the importance of the sensitive period, the first 1,000 days of life, also for the outcome of our health, as an adult, and the importance, of the exchange, of the mutual exchange between the mother and child and build our future life. This is something this paper really like this paper that not only highlight, the nexus, the relationship between the mother and child, but also third factors coming into action, that is the breast milk, so the lactation period, the breastfeeding period, that is important as well for our health outcome, also for our mothers, during the nursing periods. And there are many factors acting on the nexus that are, biological one, environmental one, but also social and cultural one acting on the nexus is what we are trying to understand, studying human remains. In this sense, teeth are particularly suitable to investigate the nexus. I mean, I'm a dental anthropologist by my original formation. And teeth start to form quite early, because with deciduous teeth start to form at the beginning of the second trimester of pregnancy. It means that the care information about the pregnant, a big period of a pregnancy of a mother, so arriving up to adolescence or early adulthood with the permanent teeth. And they are able to permanently record information about growth trajectories during infancy and childhood, of course, during the period of their formation, about health status, about diet, about mobility. We heard many of you talking about that in these days. But really important, the tissues that form prenatally during the intrauterine life tell us about the mother's health and diet and mobility during pregnancy. I mean, so we can read directly from the teeth of the offspring the information about his or her mother. That's really the strength of the teeth, and particularly of deciduous teeth. Teeth, and I will talk mainly on dental enamel. That is my, the tissue, the dental tissues with which I'm working mostly. It forms in a rhythmic manner, so it preserves a biorhythm that has a daily scale first. So we have microstructure in dental enamel that can be read in dental histological section, thin section of teeth, based on alternation of day and night. So we have 24 hours of enamel secretion rhythm. So we have a daily scale in our teeth. Plus there is a second biorhythm that in humans is of about 1 week. It's like the three of the rings, so give us another time scale. In this way, we can know in each point of the dental crown is an example of a part of a thin section of a tooth. We can know in which moment of the life of the individual we are in each point of the dental crown. And last but not least, dental enamel is less affected by diagenesis. This is really important when we need to explore the chemical composition of these tissues, as we will see later. One of these ring, is particularly important. Rebecca also talked a little bit about that in the first day. This is the neonatal line, representing the stress of birth. But it's not all important because it's a zero of our time scale, so we can calibrate the timeline, of the life of the individual at birth, but we can detect the tissues that form before birth, so those speaking about our mothers. Okay, so dental histology is a destructive procedure. So, you have to cut teeth, also, bulk analysis as well. So I've been in the cultural heritage world before being in academia, so I'm perfectly aware what it means, you know, conduct destructive analysis on archaeological or even fossil remains. In my lab, we developed this protocol that's called Nothing Goes to Waste, that we just published less than 1 year ago on Journal of Archaeological Science, to optimize, you know, the sampling of ancient teeth. That means you have two paths. You can exploit one tooth of one individual to have as more information you can gain from a single dental element, so going from ancient DNA to bulk sampling or homology analysis, histology and biogeochemistry, something we'll talk in a while, or just limit the analysis to histology and biogeochemistry, but we'll see that we can gain a lot of information from these and restore the tooth after the thin sectioning. That is, I mean, it's something that curators sometimes ask. I mean, that they, you know, you're perfectly aware what means doing destructive analysis. So this is to propose a way, I mean, to just have a compromise with the curators and can carry some kind of destructive analysis by restoring the tooth at the end. Among the information we can gain from dental enamel is diet. We've seen, you know, some example here, but I'm changing a little bit the perspective. That we use a different methodology that is the measuring trace elements across the dental crown, across dental enamel, using laser ablation, inductively coupled plasma mass spectrometry. Keeping really, you know, explaining you really simply. So forgive me, I will be, I mean, it's too simple as what I'm saying. You have the thin section, there is a laser beam that hit the enamel, that vaporizes the tissues, that is sent to a mass spectrometer that measure on the fly the concentration of trace elements in the tissue. So moving, I mean, by crossing information that we have from, I mean, the days of life across the crown with the length of the laser track, we know, you know, how the concentration of elements change through the life of the individual. So a close to longitudinal approach in this sense. We measure as trace elements strontium and barium that indicate dietary shifts because they are non-essential elements, so they are necessarily introduced with diet, so when we eat something. And we also, in archaeological and fossil remains, it's really important to control diagenesis. So we measure also elements that indicate, you know, diagenetic alteration like uranium, aluminium, manganese, or rare elements. And also, I mean, with a slightly different methodology, the strontium isotopic ratio to study mobility, but we will talk it at the end of this contribution. As for trace elements, strontium and barium, they can be used to study the onset of weaning. It's part of my ERC project. And basically, starting from birth, that is marked by the neonatal line, so you know, a real marker, the real marker of birth, we have level concentration of these elements that are those of our mother during pregnancy. Because mammary glands discriminate against these elements, maternal milk, human milk, is depleted in elements. So what we see during the life of the baby, during exclusive breastfeeding, is a decrease in the concentration of the elements until food is introduced in the diet of the baby. And as soon as food is introduced, we have a change of the slope. You can see a huge increase of the content of these elements, and so we can detect the onset of weaning moment. The same is with bottle-fed kids. We start from birth, neonatal line. Formula milk is enriched in strontium and barium because it comes from herbivore milk. So herbivore eat vegetables. Vegetables are rich in strontium and barium. So after birth, we see an increase in the content of this element until food is introduced in the diet of the baby. Then we have a change of the slope again, and we can detect also in this case the onset of weaning, so the moment in which food is introduced in the diet. We will see, you know, at the end what it could be important, you know, studying past individual. Just to give you a very quick overview of how reliable or precise is the method and how, I mean, the enamel respond quickly to the introduction of food and then the, you know, the introduction of the elements in forming enamel. This is an example of very well-known contemporary kids with a very well-known anamnestic and dietary history. It's my personal experiment, so it's my son. It's always always happy when I propose this to the conferences. Okay, he had some mild health problem just after birth, so we have neonatal line here. And because of that, we spent 1 week in the hospital, and he was subjected to mixed feeding. So we have a component of breast milk plus a component of formula milk, and you see elements are growing up, as we saw earlier. Then, because I'm quite crazy, I switched to exclusive breastfeeding after 40 days. At 40 days, we have a change of the slope of of our elemental distribution, with a decrease that we observe in exclusively breastfed individuals. And here, this small peak here is when I started to introduce fruit in his diet. Just a small amount of grated fruit, but we can catch it exactly in the period, in the days in which I started it. So, the method it really works, let's say. If we analyze prenatal enamel, so the tissues that form in the intrauterine life, we can detect, the mothers with a different diet. It's not, this is the best case. It's not that easy as usual. But if two mothers have a really different diet, so one vegetable dominated and one meat dominated diet, it's not easy to find a woman with a meat dominated diet, let's say, we can have a difference in the level of, in this case, is represented strontium calcium. So we can use it as a trophic level indicator. That is, is important. If we explore past human individuals, I will show you now an example with Neanderthals. In this paper that we published on PNAS in 2020, so quite some time ago now, we analyzed 4 deciduous teeth, 3 Neanderthals, and 1 upper Paleolithic Homo sapiens coming from northeastern Italy, spanning between 70,000 and 40,000 years before present. The sample is really important because those are naturally exfoliated teeth. So we are not talking about a mortality sample, but the individuals survived this stage of life because we found the teeth in a cave that basically have been lost by the kids dwelling in the cave. So it's important. It's not a mortality sample. So we're not looking at children that died during this period. So that's something I really care about. So we did trace elements analysis to detect the onset of weaning in Neanderthals. Here you can see one of the Neanderthal, Fumane 1, compared to a modern day child with a known diet. This black line is the neonatal line, marking the birth event. So in the Neanderthal, after birth, we have decreasing strontium calcium and barium calcium concentration. Then we have a slight change of the slope of the profile that indicates the first slight introduction of solid food in the diet of the infant, and then a much strong change of the slope indicated the real onset of weaning when food was introduced, really a stronger component in the diet of the child. All is calibrated in days of life, so we have basically the timing, of the onset of weaning in the Neanderthal. We did it for the other 2 Neanderthals and for the upper Paleolithic Homo sapiens. And what we found, is something that is not that different from what we have today. So, first introduction of food around 4 months of age, or start to give fruit to my son at 4.5 months. So basically, it's almost the same, and onset of weaning around 5-6 months of age. So nothing different from what we have today. We analyze also, of course, analyzing the deciduous teeth, we analyze also prenatal enamel, that is in the case, the mother. And curiously, we have all the Neanderthal mothers as a level of strontium calcium concentration grouped together down here, and the upper Paleolithic Homo sapiens mother up here. So it could be, it means that Neanderthal mothers possibly consuming highly biopurified food, that means more meat than Homo sapiens, something, a topic that is, going around in a paleoanthropology field since a while now. So can be a real different behavior of the 2 mothers, or possibly a different season in which the mother lived. We are just doing some analysis on the same teeth about oxygen isotopes, and it seems that, the seasonality is not one of the factors affecting, so could be an indication. I just have the data this morning, so it's a really new thing. So what we found of Neanderthal, I mean, having this, I didn't show you, but the growth rates are similar to that of our children who have a similar timing of weaning, you know, in the early life. The implication that we can assume similar metabolic constraints between Neanderthals and Homo sapiens mothers, and also, you know, a similar physiology to ours is something not surprisingly us, because we know that they interbred, so it's something, but we can, I mean, we have seen it as a direct evidence of similar things. I'm going quickly, I mean, to explore the mobility topic, just because we talk about that, you know, in the previous days. We did, I mean, with the same methodology, we can measure, you know, so using a kind of different mass spectrometer, so multi-collector, you can measure strontium isotopic ratio, as you do with bulk analysis, basically, but you can do it at a high resolution, so having the change of these values across the life of the individual. We have here the 3 Neanderthals, and baseline is in gray, and you can see that the 3 Neanderthal mothers are less mobile than the upper Paleolithic Homo sapiens mother. So again, a possible indication of different behavior, you know, in the two species, basically. Just to give you another view of you know, the use of this kind of analysis in archaeological samples, starting from this paper published by Carmen Esposito and colleagues, among which Claudio, this should be around, on a pre-Roman site in central Italy, dated to the 9th to 5th century BCE. They conducted bulk analysis on, you know, several cremated and inhumated remains, and among the inhuman individuals, you know, there was one, the grave number 17 of an adult male, dated to the 8th century BCE, that was the inhuman individual with the highest radiogenic values of strontium isotopes. Bulk analysis has been done on the permanent M1, so we selected for these individuals, again, the permanent first molar, that, as you know, it covers, you know, from birth to around 3-4 years of age. The second permanent molar, you know, overlapping partly with the first permanent molar and arriving up to 8-9 years of the life of the individual with the dental crown, so just the enamel. We're talking just about the enamel. And the third permanent molar with a small gap between the two crowns of M2 and M3, but arriving up to 15-16 years of age. And we did, you know, laser ablation analysis. So for each tooth has been divided into chronological grid representing, you know, the time in the individual life, in days of life. And this is interesting. I mean, the yellow line you can see is the values for the bulk analysis on the M1. While these profiles representing, I mean, the high resolution analysis for strontium isotopic ratio. As you can see with the bulk analysis, they catch exactly the beginning of the M1 that was quite good on one side, but on the other side, it shows you that the high resolution analysis, even if the sampling, you know, you sample much smaller quantity of enamel, of course, is reliable. I mean, the two values correspond well. But here you can see a really nuanced view of the life of the mobility, you know, of the history of mobility of these individuals, having, you know, in the first year of life, the mother and the child in the first year, children are with their mother. So we are seeing what the Nexus, you know, was doing. They moved to another place where they stayed for, you know, up to the 5-something years of age of the child. Then we have this gap that unfortunately, because the two crowns do not overlap, but as soon as the M3 start again to record the signal, the individual moved again to arrive around 10 years of age in the area or in which he was found, you know, in the burial site. So you have a very nuanced view, I mean, of the mobility history of the individual. You can imagine if you extend it to several individuals for the necropolis, you can also explore, you know, female mobilities or, you know, children mobility. There are multiple options, something in which, of course, we are working it. Just quickly concluding, you know, by using dental enamel histomorphometry, you know, the histology, coupled with high spatial resolution biogeochemistries, either for trace element or strontium isotope analysis, is a very unique tool to explore the mother-infant nexus, the relationship of these two individuals in past humans. We have seen prenatal enamel tell us about the mother's life during pregnancy. So it is amazing that from the tooth of one individual you can have direct information of a second individual that is his or her mother. And of course, there are multiple line of research that can start from it. Here is just an example, something with which we are working on for my ESC project. Of course, knowing the use of having direct evidence of non-human milk use in nursing infants, even in prehistory, could be a kind of a good line of research. So, I hope that can be of a kind of inspiration, or open to collaboration as well. So, thank you so much. Just thank you, a lot of people. That's not all my work. Many people, collaborators, colleagues, and I would like to thank you, and thanks for your attention.